Hello and welcome. In this short video we will be taking a look at polymorphism and the notion of overriding methods. Now we will have discussed in previous videos the idea of overloading methods, but this is a new concept, a different concept known as method overriding, where we have multiple methods that appear to do the same thing but one will override the other. Okay, and it's a concept specific to polymorphism and inheritance. So first off, what is polymorphism? The dictionary definition of polymorphism refers to a principle in biology in which an organism or species can have many different forms or stages. So it's this idea of multiple forms or many forms. This principle is then also applied to object-oriented programming languages like Java, and what we have then is we have methods in a particular application that can have many forms. So one method can have many forms and can have different behaviors, okay? So subclasses of a class can define their own unique behaviors and still share some of the same functionality of the parent class, okay? In object-oriented programming languages such as Java, the definition is polymorphism is the ability to refer to an object using its actual form or a parent form. So we can refer to the method from the subclass or from the superclass. So, as usual, the best way to look at this is through an example. And in the previous videos on inheritance, we've been looking at this idea of an assessment application, where we will store the data or the relevant information of different assessments. And we had a superclass assessment, which had name, type, and weighting, and we had subclasses of project, test, and then we went on further and extended test to include Moodle test. So in the superclass we have all of the common attributes, name, type, and weighting, and then in the subclasses you have those attributes that are unique to the subclass itself. Okay, so the class diagram looks like this, just to give you a reminder of how it worked. So you'll see we have name, type, and weighting in the assessment class, but we had deadline in the project class, and we had num questions and duration in the test class. Those are attributes unique to those particular classes. Okay, and if we take a look then at the code for the assessment application, we had assessment was our superclass, name, type, and weighting, and getters and setters for each of those. We had test with num questions and duration, inheriting everything from the superclass. We called our super constructor in our constructor because the one thing we don't inherit from a superclass is a constructor. And then we had getters and setters for the new attributes. The same then applied with project, which had a new attribute of deadline, and we had Moodle test, which had further data members, open, closed, and password. Okay, for now we're just going to focus on assessment and test. So, supposing looking at this problem, we've created all of these objects and they store all of this data, but at some point we want to print it all back out again. And maybe we want to make one method called getDetails that's going to take all of those attributes and put them in a string for us so that we can print them to the screen or do whatever. Maybe we want to store them somewhere else. So if we take a look at assessment, and so this is our superclass, okay, we know that it's got this symbol here in netbeans, has subclasses. And let's just go down the bottom. Doesn't have to be down the bottom, the order of the methods in this class don't matter, but we'll just pop it in down here, and we're going to add a new method, public string get details. Okay, and what we're going to do in here is we're going to return a string, and that string is going to have all of the details in it. So name plus name. Okay, then we'll have a new line, so our new line is \n, okay, and then we had the type. We'll add in the data member for type, and then again we'll have another new line, and we'll have weighting, and then the data member for weighting. And then just for good measure at the end, because weighting is going to be a percentage, we'll add in the percentage sign there. Okay, so we've got our getDetails method, which takes name and the data member of name, type, the data member type, weighting and the data member weighting, and it puts them all into a string and returns that string. Okay, that then allows us to go into our assessment app, and you'll see in here in earlier examples we had declared an instance of just assessment called A, and we had OOP project terminal as the type and 30 as the weighting, and then we had another assessment B which had OOP exam, terminal examination, and 70. So let's now at the very bottom use the get details method to retrieve details of A and B. Okay, so system dot out dot print ln a dot get details okay. Oh, that didn't come out right. And system dot out dot print ln b dot get details. Okay, and let's just save all and run that. And here you'll see name OOP project, type terminal, weighting 30%. Name OOP exam, type terminal, weighting 70%. Perfect. Okay, and that's fine because we're just trying to get the details of A and B. Later on in examples we went on and we created a project P and a test T. Okay, and obviously projects have more details than a regular assessment, and tests has more details than just assessment. So let's try again. Use the get details method to retrieve details of T. Okay, system dot out dot print ln t dot get details, and you'll see now name OOP exam, and that was what we had. Type terminal exam, that's what we had in here. Then we had our 70 for our 70% weighting, but we're not getting our 10, which was our number of questions, and our 60-minute duration. Okay, so what we'll need to do, okay, because the assessment class doesn't have duration or number of questions, so it's not concerning itself with that. If we try to add in \n duration plus duration, it doesn't know what duration is. You can see that there. Okay, duration doesn't exist in the assessment class. Duration only comes into play when we get to the actual test class, the subclass. Okay, so we'll go into the test class, and what we're going to do in here is we're going to override the original get details method. Okay, so that when we try to print the contents of the test class, it will use this method instead of the one that was in the superclass. So public void get details, sorry, not void, string, because we're going to return a string, and then we return, okay, super dot get details, because that's going to do whatever the get details method in the superclass does, plus duration. Let's do a \n there also. Plus duration and \n for our new line, and num questions. And num questions. Okay. And a semicolon. Okay. So you'll see this class is not taking issue with duration or num questions because they're declared here. Alright. We do have a warning here. add at override annotation. So in the interest of good programming practice, what we should do when we override a method in a superclass, we should add the at override annotation, and that's all part of being clear about what it is we're doing in our code. Alright, we can look more at annotations in other videos, but it's good practice for you to add that when you're writing a method which overrides another method. Okay, so essentially what we've got here now is we've got a getDetails method in the superclass and a getDetails method with the same method signature. So you'll see when we talked about overloading methods, we couldn't have two methods with exactly the same method signature, okay, but in any one given class. But here what we've got is they're separate classes. One is a superclass, one is the subclass. They've got identical method signatures, but this one, because it's in the subclass, can override the one that's in the superclass, and we do that by calling the one from the superclass and then adding to it. Okay, so if we go back now to our assessment app and we run this again now, t.getDetails, I haven't changed the command. I'm going to try to retrieve the details of a test. Okay, and you'll see here now, name OOP exam, type terminal exam, weighting 70%, duration 60 minutes, number of questions 10. If I was to change this back now to an A or a B or for some other subclass of assessment and run it again, it's only going to give me name, type and weighting. Alright, but once it takes the method from the object. So I call getDetails and Java checks, is T an instance of assessment or is it an instance of test? And if it's an instance of test, then this is the method that it's going to run. And that's the important thing to note. Okay? So just a reminder there then. Alright, we should we need to use the super keyword, which we used in our constructors already when we did inheritance. So we're familiar with the super keyword, but the constructor is not the only place where it's suitable for use. Okay? And then we need to use the at override notation when we're going to override a method. Okay? And when we call an overridden method, the correct version will run depending on the type of the object. So I hope this has helped you to understand polymorphism and overriding methods, and please watch out now for the follow-on to this video, which will look further at constructing objects and polymorphism. Thank you.